Alright, so question 3, mind. Question 3, the experiment below was used to verify a relationship between the acceleration produced and the net force acting on an object. Learners set up the apparatus as shown in the diagram below. The apparatus is equipment abawusebenzisayo. So in the science lab it's called the apparatus. Depending on how you pronounce it. So now lama diagrams because of space. So now we have a ticker timer, we have a ticker tape, we have a trolley inclined runaway, we have a string connected to this pulley. Now I'm a mass pieces and then it grounded. Okay, so we have a graph of acceleration versus net force. Now acceleration, now net force. But I totally level my points. So let's start with drawing the graph, which is question 3.1.2. And then we can go to 3.1.1. So, but this is how it looks. So therefore, when you any question paper, 6 send there, like WhatsApp. So as you can see, and then goes and square and then umbuzo write down the name of the quantity that must be kept constant in this experiment. But since just in the space lab, we will start with 3.1.2. On the diagram sheet provided on page 16, and then draw the graph that can be expected. Be sure to submit the sheets with your answer book. 1 mark. Join our dots. But you have to draw the line of best fits. Line that will touch our dots, amaning, or straight. We are about to my sugar go 0. Izohamba la 8 ngeke izimthinte lo izothinta lo ngoba once yamthinta lo isizohamba la ibashiye bonke lapha yabo. So uline of best ukuthi uthinte the most dots okusho ukuthi uzothinta 1 2 3 4 amgeje kancane lo kuzosala lawo wo 2 kunokuthi athi 1 2 3 mesashiya abo 3 yabo. So siyasusa la iqaleni izohamba la ize la izodlula la idlule la sekusala kancane la iqhubeke yelena kodwa iyona graph yakho le kumele ujwe but wena usebenzisa i-ruler ukuze ibe more straight yakho usebenzisa i-ruler nje udwebe kanje and then ke uzofaka lama labels vele lawa ade vele ekhona but wena usebekunikezile vele yonke into wena umsebenzi wakho is just to draw. So this was question 3.1.2 lo just qhubeka sidwebe ini le graph le and then ke manje sesobuyela ku question 3.1.1 and then siye ku 3.1.3 sihambe ngendlela kanjalo kanjalo. So if una question paper phambi kwakho you should follow. Mawunganayo listen wenze sure ukuthi question uyayicela next time you doing this paper ukuze ungabi nenkinga. Asambe sekona question 3.1.1. Alright, so nangu lo mbuzo tengiusho manje ade kumele siqale ngawo. Write down the name of the quantity that must be kept constant in this experiment. So yini emele ibe constant, yini le ekumele ingashintshi okuyiyona phela into enga affect izinto eziningi. Ziningi izinto ezikhona and the most obvious answer for 3.1.1 is mass. Mass may be constant every time. Le mass le trolley ayingathi sithi mhlambe i1 kg ayingathi mesephinde experiment isu 2 kg mesephinde experiment isu 0.5 yabo yonke into le because that will affect the data because of your weights. Nama mass pieces lawala you can't change the mass le lana because if you do you changing yonke into eyenzakala la and therefore you are preventing ukuthi i-experiment ihambe ngendlela ngenxa yokuthi this important quantity esibiza nge-mass is not kept constant. Yabo? So which is why la besibuza ukuthi yona yiphi kumele ibe constant which is just in mass. So ukuze understand ukuthi why kuthiwa kumele be constant. Mekuthiwa constant they mean it won't change, ngeke izishintshe, but konke okunye will be affected by ezinye izinto. Therefore i-mass does not affect the experiment because it is kept constant. So uma ukuthi bayafeyila mhlawumbe le experiment mhlawumbe ayenze ngaleyo ndlela ayiphumi kahle, ngeke basho ukuthi ingenxa ye-mass because the mass was kept constant. So kuzoba amanye ama-factors, it's easy to determine iy'nkinga later on uma usuqedile because you know ama-factors akho they were constant, which means kungenzeka kube ilokhu nalokhu, but hayi i-mass. I-mass plays a big role, which is why benama-mass species alingayo la. Asini manje ku-question 3.1.3. Alright, so 3.1.3 states in words the mathematical relationship between acceleration produced and the net force acting on the object. Mawukhumbula kahle i-diagram, i-graph of i-acceleration nani ne-net force le kade sinayo ibihamba kanje, sidwebe yanyiwa kanje, yakhumbula. So which means straight line there, so means lapho qonda ukuthi when one quantity increases the other will increase as well. Ukusho ukuthi bazonyuka bobabili, or uma behla bazokwehla bobabili kahle kahle. So the relationship between the acceleration and net force, according to Newton's second law, futhi uyasho ukuthi when a net force acts on an object, the objects will accelerate in the direction of the force at an acceleration that is directly proportional to the force and inversely proportional to the mass. Ngakho ke between acceleration, the rate of change of velocity, and the net force, which is a vector sum of two or more forces acting together, yini relationship yabo 3.1.1 imake load directly proportional. Why directly? Remember the graph was an increasing graph. Therefore, as x increase, no bayanyuka. So which means bayanyuka bobabili ngerate efanayo. Therefore, they will be directly proportional and not inversely. Kube be inversely proportional igraph yabo ibizoqala phezulu iyehlile kanje. That is inverse proportion. So there it is direct proportion whereby two quantities, in this case the acceleration produced in a net force, those two quantities, when one increase the other will increase as well. They are directly proportional. So imali lakho elilodwa leli esidluleni kumbuzo olandelayo. Alright, question 3.1.4. So la, use the graph to determine the acceleration of the trolley when the net force is 0.25 Newton. So when you take the question paper yakho le onikezwe yona, la wenze njani, la usujoine khona ama dots, which is what we're doing eqaleni. Ile nto ozobusiyibuka le onikezwe yona, even if awudwebile, the answer is on the graph le abakuphe yona bona. So how do you get the answer yakho? Acceleration on the graph equal y-axis, but in net force equal x-axis. So la in net force you 0.25 khona, which means la ku x ku 0.25 uzonyuka uzoyithinta igraph mase uya ku y ucheck ukuthi imthinta y. So u 0.25 kwi graph yethu ula, and then so uma sinyuka siyofika ku 0.5 uqondene kanjalo. So therefore uqonda ukuthi i-acceleration yethu izoba u-0.5 meters per second squared, which means the velocity of a trolley is increasing by 0.5 meters per second every second. Qonde lokho le number le or le answer le esiyithola njengoba bese determine the acceleration of the trolley when the net force is 0.25 newtons. Yabo? U2 marks wakho nje lo osubhalile njengoba unjani. So we will move on to umbuzo olandelayo to calculate the mass of the trolley. Asambe siyophendula. Alright, 3.1.5. For 3 marks to calculate the mass of the trolley. So yazi ukuthi F net is equals to MA. So M is equals to F net all over A. So, kule graph onikezwe yona ke. Le graph onikezwe yona ku question paper yona oyisebenzisayo. So, buyela back kuyona kanje, and then you look for ama-point awu-2 azo correspond, just like u-0.05 no 0.1, just like u-0.1 no 0.2, just like u-0.2 no 0.4, just like u-0.25 no 0.5, just like u-0.35 no 0.7. So if in net force use 0.35, so M is equal to 0.35 all over, and acceleration that is over 0.7. So therefore mass yethu isizokuba link. So 0.35 divided by 0.7. Mass yethu is 0.5 kilograms. Yabo? Umoya ngathatha ipoint elu 0.2 no 0.4. So 0.2 divided by 0.4 still so 0.5. Elinye point 0.05 no 0.1. 0.05 divided by 0.1. Now it is still 0.5. So any point that lies on the graph, we divide in number, we thought for 3 marks any mass of any trolley, and that is it. I go into a complicated, or you could use 1 all over M is equals to change F net like this answer, and then there is a change in acceleration. Or you could use E gradient, y2 minus y1, y2 minus y1 divided by x2 minus x1. But obviously it's just use Newton's second law. F net is equal to MA. Whereas with F net is your net force. You take any value that corresponds with a point on the graph. You divide to the answer. So mind you, we'll be moving on to question 3.2. Mind, that's how question 3 though. What did another experiment? So now we'll be going to question 3.2 with the new statement, new graph, konke kusha. So mouse uhambe kahle kule question up until this far. So manje check umsebenzi wakho ke manje. Ucheck ukuthi are your calculations correct yini? Ngayo yonke into kade uyibhalile uyibhale ngale ndlela kade ufuna ukubhala ngayo. And only then you can move on to question 3.2. Sambe siyobheka. Okay, now we'll do question 3.2. So we have done. So 2 crates of mass 25 kg and 50 kg. So my case amabili 25 kg no 50 kg are connected by a light inextensible rope. Baxhumene ngentambo engasindi light enganwebeki futhi inextensible rope. A force of 200 newtons is applied to the right. Nangu umuntu la uyadonsa no 25 kg oxhumene nalo 50 udonsa ngo 200 newtons. Udonsa uyaka right ngala uza ngakuyena, as shown in the diagram below. Nansi ke diagram. And then wasebathi the crate moves with an acceleration of 1.25 meters per second squared to the right across a rough, friction, across a rough horizontal surface. The coefficient of kinetic friction is the same for both crates. So iyafana a coefficient of kinetic friction. What's the state Newton's second law in words? Second law has the F net is equal to MA, and it's F net directly proportional to A and A inversely proportional to M. You're not in Newton's second law. But yeah, see, when a net force or resultant acts on an object, the object will accelerate in the direction of the net force at an acceleration that is directly proportional to the net force and inversely proportional to the mass. Iona in there, Newton's second law of motion in words. Okay, so 3.2.1. When a net force acts on an object, the object will accelerate in the direction of the net force. So when a net force acts on objects, the objects will accelerate in the direction of the net force. At an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. So marks are cool, John. Also told it. When a net force acts on an object, the objects will accelerate in the direction of the force at an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. Iona in Leo in Newton's second law in words. So mind you'll be continuing with our questions. I come back after this. Asambence your pen. Alright, so draw the labeled free body, which means any dots, any objects. Free body diagram to show all the forces acting on the 25 kg crate. Wonke ama forces there. 5 marks. Into engakutshela ngathi make 5 marks baqonda ukuthi shoot ama forces ekumele include on your free body diagram. 5 now. So, any dots. So we start drawing any dots. First things first. We know there are two forces angabonakala, which is gravity and normal force. Since koni surface, therefore koni gravity la, and it is balanced by any normal force. So we have Fn la, and then going down we have Fg. And then our horizontal forces, we have the 200 newtons, right? 200 newtons. So it's now Fa. And then, because this is the applied force. Oh, I'm going to tension since we rope. But get any tension is Ft, tension. What do we also have? On a rough horizontal surface, kinetic friction. Therefore, we call so you as Fk, which is the kinetic frictional force. And then from here on, you'll be getting 5 marks work. So 1 mark, 2 mark, 3 mark, 4 mark, 5 mark. A free body diagram yakho. Olula ongawubangiswa umuntu. Yabo? So we need to practice drawing our free body diagrams. For 5 kg, we will have tension, the friction gonna pen. Yabo? So remember, muscle by again, we're only looking at our horizontal forces. Labas, that big. Gases and this is by now. So after this, let's go on to the next question. Alright, so now 3.2.3. So use relevant calculations. Show that the coefficient of kinetic friction for the crate is 0.144 or 6 marks low. So those are many solve for any frictions, both sithola. Yeah, and then remember this is 50 kg and this is 25 kg. So la 50 kg, if we have Fk as the kinetic friction, therefore la we have 1/2 of Fk, half of the friction. Because of the masses of 50 kg la 25 kg. So let's just start with 50 kg. What we know is F net is equal to MA. And let's pick right is positive. Right is positive. So we have the free body diagram. Yeah, 50 kg. Ukona Ft la nani? No Fk. So Ft plus negative Fk is equal to Ma. So Ft as mass, so we'll keep it as Ft minus fk, which is friction asiyazi nayo izosinikeza 50 times 9, no, it's not 9,8, it's not a G, A, but say 1,25. 1,25. So, sesiyazi shuthi nje kahle kahle ft we will make by subject of formula, it doesn't matter. ft minus 50 multiplied by 1,25, 62,5 minus 62,5 is equals to friction rate. Yabo? Asisethe nje lo equation 1. Omunye bengasho ukuthi ft is equal to 50 times 1,5 plus fk. So now let's do in 25 kg. So for 25 kg now, if we body diagram yakhona, what we have la, we have the 200 newtons long it, and then we have half fk, and then we have the t. So again nala, so choose rise is positive. F net is equals to ma. So we should go 200 newtons minus 1 over 2 fk minus ft is equals to 25 manje times 1,25. So sesizothi 200 minus 1 over 2 fk minus 25 times 1,25 31,25 is equals to ft. So kahle 200 minus 31,25 168,75 minus 1 over 2 fk osinikeza ft. Yabo? So what we could do lana, let's just let's not make this equation 1. Asenze kube ft is such a sort of formula. ft khona bezofana nala. ft uzoba 50 times 1,25. 62,5 and then plus fk is your equation 1. So le is our equation 2. So we have to equate our equations. So this is 62,5 plus fk uzosinikeza 168,75 minus 1 over 2 fk. Okay, so I'm like terms obviously fk plus 1 over 2 fk uzosinikeza 168,75 minus 62,5. So 1 plus 1 over 2, so 3 over 2, so this will be 3 over 2. fk uzolingana no 168,75 minus 62,5. Lower 103,25. So therefore fk so 103,25 divided by 3 divided by 3 over 2. Lower usinikeza 68,83 newtons. In there friction yethu. But guess siyazi ukuthi fk phela is equals to coefficient multiplied by the normal force. So coefficient kahle kahle ilingana no 68,83. Khumbule ukuthi ngizoyibhala ngala ukuthi normal force ilingana no mg, normal force yala. So izolingana no 50 times 9,8. So 50 multiplied by 9,8 490 newtons. So divide and 490 and then 68,83 divided by 490 snikeza 0,144. So we have proven ukuthi ngempela the coefficient of kinetic friction for the two crates is 0,114. Azama ukubona ngala ukuthi kuzofana yini. Normal force yala izolingana no mg, so 25 times 9,8, so 25 times 9,8, 245. So lapho sesiyazi-ke ukuthi half fk la is equals to, okusho ukuthi lona uzosinikeza uma simultiply ngo2 kusho ukuthi 2 times 0,144 times 245 isibothi usinika ba ngiyaphambanisa uma half fk izosinikeza ukn, kusho ukuthi ukn ulingana no half fk divided by normal force. So kuzoba half sibothi izophuma ila kanje, half multiplied by 68,83 divided by 25 times 9,8 sinikeza 0,144 nala. Yabo, so our answer is correct. Yabo, but ke uzomele ujwayele ukupractice lesibalo kanje ukuze uzokwazi wenza njani ukuthola kuba nje this is 6 marks. U6 marks lo ubalekile ekungamele ulose. Yabo, so the next question is 3.2.4 and then sobe sesiqedile ku question 3.2 sesiya kolandela sikade kodwa ngo question 3 mude nje kabi maningi ama questions la msho nawe uyabona mawusunalo leli paper since it is a previous paper. Yabo, asambenise question elandelayo. Alright, so lo mbuzo manje uthi calculate the magnitude of the tension T in the rod. Tension la uthatha ama equations la wadu wasebenzisa for the 6 kg block, for the 50 kg block njalo sithole lo equation 1, for the 25 kg block sithole equation 2, and fk simtholile as 68,83. so T is equals to 62,5 plus fk, which is 68,83, or T should be equals to 168,75 minus 1 over 2 of 68,83. La khona nje fk sifaka, we are substituting 68,83. So 62,5 plus 68,83 gives you 131,33. 131,33 newtons. Let's see now, so let's find 168,75 minus 1 over 2 of 68,83. Sithola 68,83 134,33 newtons. 168,75 minus 1 over 2 of 68,83. Yes, and then we'll have this test 62,5 plus 68,83, 131,33. Yeah, so the only difference lana 131 got 134. So I think the main reason is we round off, since the 68,83 is actually 68,8333 recurring. Yeah, well, it is an irrational number. So therefore, njoba kade sisebenzisa le number around of here all this long, it was giving us the answer is will be deviator kancane from the actual answer. Yeah, but yeah, this is how we use it when we use our two equations. Ukhumbule nalapha lebesihamba round off yonke leyo ndawo, which is why our answers are kuhluka kancane. But as you can see, let's just say 134 is the correct answer. With now we are we are 98% correct. Yabo? If it's based on what le correct, that means le is 98% correct. Mainly why? It is because of rounding off phezulu mawusabala. Yeah, iyakhelana lo nto. Yabo? So this is how you do in magnitude of the tension in the rope. Sengumbuzo landela.